Okay, so chapter 14 is the final syllabus, final chapter for the syllabus of Eco 201. It has to do with integration. So this is something that's completely different. So if you all remember, we started off with 2 chapters of matrices. Then we did 3 chapters of differentiation. Then we've done 3 chapters of optimization, which you may say is a subcategory of integration in itself. And so today we're going to do, today and the next lecture, over this week, we're going to do a final chapter of integration. Or formally it's called integral calculus, but you may also call it integration. Both terms are fine. So integration, as you will see soon, is basically the opposite of differentiation. So there are 4 things we're going to learn from chapter 14. So there's indefinite integrals and definite integrals. So we're going to do that today. And I don't know, maybe we will do integration by substitution today as well. Let's see how long it takes for me to get through the material. And then in the next lecture, we will be completing the syllabus, which includes integration by parts as well, which may be a little bit tricky, but the first 3 parts will be pretty straightforward. So let's jump straight into it and talk about effectively what is integration. Let's start with differentiation, the most basic form. So if you have y equals to fx equal to x to the power n, and we want to differentiate this. And so what we write is dy by dx, or f prime x will be equals to what? X to the power n minus 1, and we put n here, right? So for example, if we have y equals to 3x to the power 4, dy dx would give us 12x to the power 3. So that's this formula, using this formula right here. And of course, you guys have done a lot of differentiation, so all of you know this one. Integration is basically the opposite of differentiation. So if we start off with fx equal to xn, and we want to find out which function we will have to differentiate to get xn. We do something called integration. So the formula for that is, this is a symbol for integration, okay? So this looks like a stretched elongated S. So what we want to do is integrate the function that we have with respect to dx. Or what we write is we want to integrate the function with respect to dx, or with respect to x. And the formula for this is x to the power n plus 1 divided by n plus 1. Okay, so as always, things look messy, things doesn't make sense. Once I go through the first example, hopefully it becomes clearer. Okay. So suppose we have y equals to, what do we have? 3x squared. We want to integrate this. Let's say we integrate 3x squared dx. Okay. So let's use the formula. Now, a constant, you guys know what to do with constant in calculus. So we hold this and let's focus on the x squared right here. And let's take a look at this formula. So we have x to the power 2, so plus 1. We divide this by 2 plus 1. That's just this formula right here. And so what do we get? 3x cubed divided by 3. So 3 and 3 cancels out, and we're left with x cubed. And so when we integrate this, we get this. Now remember when I said that integration is the reverse of differentiation? This is why. What happens if you differentiate x cubed? You get 3x squared. So what you had. So basically what we have done is we've taken this function. Well, let me use another ink. We've taken this function and we've applied this formula, this one right here, which gives us a value, which tells us that if we were to differentiate this function, we would go back to the origin. And that's effectively what integration is. It's sort of going back. I mean, okay, technically that's not it. Integration is its own thing and it has a lot of different applications in calculus and whatnot. But at our fundamental basic level, it's fine to say that integration is just the opposite of differentiation. Although technically that may not be correct, but we don't need to worry about that right now. Okay, so one thing is that integration is not completed. Okay, so this is not our answer. We still need to do one more thing. And let me show you guys what that is. If we have x cubed and we differentiate this, so d dx of x cubed, we get 3x squared. Simple enough. If we differentiate x cubed plus 7, what do we get? We still get 3x squared. Effectively, x cubed to the power plus anything. K can be anything. Anything as in any constant value. We will get 3x squared. So what you see is the differentiation of this are the same. So if integration is the reverse of differentiation, what we have to do is, after integrating, we have to add a c, which is constant, plus c plus c. Let me get rid of all these markings. We add this c because we do not know if we have a constant, if we have this 7, if we have this k, we do not know that. So whenever we integrate something, we add a constant to the answer, okay? And now the value of this c can be anything. It can even be 0. But for our purpose, it has to be added. So let's take a look at a few more examples. So we have 3x squared. Okay, we've done 3x squared before. So 7x squared plus 9x plus 4. So we have this. And we want to integrate this. So integration of 7x squared plus 9x plus 4. And we're integrating this with respect to x. Right? Now we can separate them just like we can in differentiation. So we can integrate this, plus we can integrate this, plus we can integrate this for dx. So once again, just keep this formula in mind. So what we are going to get in this first expression is 7x to the power 2 plus 1 divided by 2 plus 1 plus c1, the constant, plus for the second part, 9x, we have x to the power 1 here. So 1 plus 1 divided by 1 plus 1, which is 2, plus C2 plus, now here's the tricky part. We have a 4 here. But we can also say this is equal to 4 to the power x to the power 0 dx, because anything to the power 0 is 1. Right? So when we integrate this, what we get is 4x 0 plus 1 divided by 0 plus 1 plus C3. And so what do we get? We have 7 by 3 x to the power 3 plus 9 by 2 x to the power square plus 4 x to the power 1 plus we have C1 plus C2 plus C3. Or we can just lump them together and say plus C. So basically integration of y is equal to this value. If you want to verify your answer, you can of course do that. Let's, if we differentiate this, what are we going to get? So if we differentiate this, sure all of you can do it by now. It will be 3 times 7 by 3 x to the power 3 minus 1 plus 2 times 9 by 2 x to the power 2 minus 1 plus 4 x to the power 1 minus 1. And we have a constant here. What happens when we differentiate a constant? It becomes 0. So 3 and 3, 2 and 2. We are left with 7x squared plus 9x plus 4. This is pretty much exactly this. And that's really it. That's all there is to integration. As long as you guys remember this one formula right here, we remove all these markings. As long as you guys remember this one formula, and as long as you guys remember to add a constant at the end of your integration, that's all you need to know really for basic integration. And that is it for indefinite integrals. Okay. So what we have done so far is known as indefinite integral. So of course you guys know that I will be solving some problems later on in one of the later videos. But this is basically it for indefinite integrals. And you guys may want to practice a little bit. So I don't want to write down some problems. Why don't you guys try and solve some problems from the book? And that should be good practice before we move on to definite integrals.